Assalamualaikum everyone, welcome back to this channel. This is me Ari Wahid, and in this video we are gonna to start infrared spectroscopy. So in the previous lecture we have started the introduction of spectroscopy. We have studied at what it is. Now in this lecture we are gonna to start what is IR spectroscopy. So it is actually a type of spectroscopy. So same things are there as we have defined the spectroscopy in the previous lecture. A spectroscopy can be defined as it is the interaction between the matter, your sample, and the electromagnetic rays. Similarly, in IR spectrometry, you are study the interaction between. You are gonna to study the interaction between your IR radiation, your electromagnetic radiation, and your sample. So here we have take a specific type of electromagnetic radiations. So as in the previous video we have studied the electromagnetic spectrum, like we have studied what is gamma rays, x-rays, then we move from right to the left. We have studied what is visible region, what is IR region. Now after the visible region, IR region came in front of it, and we have divided the IR region into three parts. As you can remember, first region is the near infrared region, second is the mid infrared region, and last is the far infrared region. So we have studied about it, that what it is. And so now in IR spectrometry we have specified the electromagnetic rays that they will belong to the IR portion, and their wavelength will be specific. And then we will observe the sample, that whether it absorb all the IR rays, or whether how much of the IR rays it emits out. So this is the major principle that we have to follow. So now what is IR rays, or you can say what is IR light? So it is a type of electromagnetic radiation. So it is a type of EMR, electromagnetic radiation, that has the wave region longer than the visible but shorter than the radio wave, or you can say the microwave. Because first your visible region came here, then the region of IR came, then your micro, or you can say your radio wave came here. So that's why the wavelength of your IR is between the visible or microwave or radio wave region. So the wavelength of your IR is is more than the visible region but less than the microwave. If you talk about the energy of IR, so its energy of visible region is more than the IR, and the energy of microwave is less than the IR. Similarly the case will be the with the frequency is. So that these are the things that you have to remember. Just imagine within your mind that IR is between the visible or microwave. Next you have to just talk about their wavelength, energy, and frequency. So wavelength is increasing. So here the wavelength is like that. As we move toward it, the distance increases. Here the distance is very low, very low. The wavelengths are very close to each other. As it moves, it further increase like that. Okay, so wavelength will increase here, and if we move backward it will decrease, and energy or frequency will decrease here, and we move backward it increase at that side. Okay, so this is the shortest way to remember it. Now there are some key points of infrared spectroscopy. The first key point is about the infrared radiation. So it lies between the visible light और द माइक्रोवेव. ठीक है, ये दो इन दो के दरमियान है, ये तो बात हमें पता ही है. ठीक है. सेकंड, वेवलेंथ क्या है? द वेवलेंथ longer than the visible light. ठीक है. Visible light wavelength is low, IR wavelength is high, and microwave has more higher than the IV radiation. If we talk about the energy or frequency of visible light is high, but the energy or frequency of IR is low, and the energy or frequency of microwave is further low. Okay, So this is the way that you will write about it. Okay, now they have make the visible spectrum here again, which I have drawn in the previous lecture, and they have divided your IR radiation, and in the IR radiation your molecular vibration will occur. And this IR region has three regions: near infrared region, their range is also given here. So let's talk about the three regions of IR light. It has three regions. First is the near IR region. Its range is from 0.8 to 2.5 micrometer. Okay, then the third region is the mid IR region. If we talk about its range, so it is from 2.5 to 1.5 micrometer. Similarly, the last region is the far region, and the range of it is from 15, or you can say 1.5 to sorry for that. So these are the three regions. Near region is from 0.8 to 2.5. Mid region is from 2.5 to 1.5, and far region is 5.2 200 micrometer. Okay guys, now we will talk about the principle of IR spectrometry. Okay, so principle of it very important. As we have discussed the principle of IR, we will talk about the molecular vibration. So in this IR, molecules vibrate. Molecular vibration. Okay, so how the molecule vibrate? Let's consider any molecule which is like alkane molecule, CH3, CH3. Okay, these two molecules connect via bond. Now, how molecules vibrate? Let's consider CH3 as a ball. This is a ball, and the other CH3 is also a ball, and both are connected by a spring. And when the IR spectrometry done on them, they will vibrate. They will move it around circular motion. Okay, they will move like that. Okay, so the molecules here will behave like a ball, and the bond between them, like this bond, it will behave like a spring there. When we apply IR frequency, when it match with the natural frequency, and this bond absorb the energy and cause vibrational transition. This is not the energy transmission, this is vibrational transmission, because now your molecules start to vibrate. They will be vibrating with each other. So here in the circular movement it will be rotational. So now the molecules vibrate like that. Okay, this is the vibration, this is the rotation. Okay, so now your molecules will vibrate. ओके लाइक दैट स्प्रिंग, लाइक ये एक दूसरे से यूं दूर जाएंगे और फिर करीब आ जाएंगे, लाइक दैट, इस तरह की वाइब्रेशन होगी इनके दरमियान में. ठीक है, and why this vibration take place, or why the dipole moment is changed after absorbing a IR? Because of the covalent bond oscillate. Now your bond is oscillating, it is increasing the distance, then decreasing the distance, it is increasing the distance, then decreasing the distance, then increasing, then decreasing. This kind of oscillation is that's why the dipole moment is changed. So it's mean dipole movement will change when the IR spectrum is. So it's mean when we fall a high energy or intense IR, we if we fall the intense IR, it's mean there will be more dipole change. If we fall less intense IR, it will be that dipole moment change will be low due to it. Okay, so they will be the all your diatom molecules, always diatom molecules. So this is diatom having two atoms in it, they will vibrate. Only one atom like CH4 how we can observe it, oscillation or its vibration. To observe the oscillation, we have to take a diatom having two atoms, two molecules. Then we clearly see how they will oscillate, or how they vibrate, and how their dipole moment is changed. Okay, so vibration of diatom molecules oscillates the spring, and whenever they oscillate, they produce couple waved. Okay, they produce couple of waves. Like normally their wave should be like this. Okay, this is the normal if they have doing the normal vibration. But when they excite, when they absorb the, like when they absorb the IR radiation, they oscillate and they produce couple of waves. Like they produce a couple of waves as I am showing. Thus, this is the couple of wave that is produced because the IR spectrometry observe over it, and due to which these kind of couple waved are produced. Now there are some types of molecular vibration. Now let's study the types of molecular vibration in which our molecule can vibrate. So molecular vibration has two types. First type is the stretching vibration, and second is bending vibration. These two types. Now your stretching vibration, it is again further subdivided. First we will study what is stretching vibration. So the oscillation occurs along the bond axis, along the bond length. This change is called stretching vibration. कि क्या हो रहा है कि ये आपके दो एटम्स हैं, ठीक है, ये उनके दरमियान में कोई भी स्प्रिंग या बॉन्ड है, ठीक है। दोनों मॉलिक्यूल्स जो हैं वो क्या कर रहे हैं, एक ही डायरेक्शन में, एक ही बॉन्ड एक्स में ही ओसिलेट कर रहे हैं। या ये वाला मॉलिक्यूल इसकी तरफ जा रहा है, या दूसरी तरफ ये वाला मॉलिक्यूल इसकी तरफ जा रहा है, ठीक है। एट अ टाइम एक चीज़ होगी, या ये मॉलिक्यूल इसकी तरफ आएगा, या एक और सिचुएशन में एक और मॉलिक्यूल में ये वाला मॉलिक्यूल इस तरफ, यानी एक डायरेक्शनल, वन डायरेक्शनल मूव. So this is the oscillation that occurs along the bond axis. Now the bond length change. ये bond length change होगी, या तो ये एक दूसरे के बहुत करीब आ जाएंगे, लाइक इस तरह हो जाएगा, या एक दूसरे से बहुत दूर फिर चले जाएंगे, फिर इस तरह आ जाएंगे. सो बॉन्ड लेंथ इज चेंजिंग. दिस द बॉन्ड लेंथ, ये कभी कम हो रही है, कभी ज़्यादा हो रही है, कभी फिर कम हो रही है. सो नाउ द बॉन्ड लेंथ इज चेंज इन स्ट्रेचिंग vibration. Now your stretching vibration can be symmetrical or can be asymmetrical. Symmetrical change mean, for example, if we have triatom, for example, let's consider a triatom, because when we consider a triatom, it will be easy for you to understand. For example, we have the three atoms or three molecules here that connected with each other with a bond. Let's give them the name. This is the A, this is B, or this is C. Now the stretching occur between them if both of these bond, like it moves away from you and it also moves away from you, both are moving far away from the B atom, it's mean it is symmetrical. Both bonds increase or decrease in the length simultaneously, like both bonds increase their length. After the stretching, this A will moves here, this C is moves here, both bond length increase. Or let's consider other case in which both bond lengths decrease, like this is the B, this is A, and this is C. Now their bond length is decreased here. This is the symmetrical stretching. Now in the asymmetrical stretching, one bond will move away while the other bond will move towards the B. This is stretching, that one bond is increasing its length, for example, and the C is not increasing its length. C is decreasing its length, like that. This is the asymmetrical. Now there is no symmetry. First we have the symmetry, both bond lengths are increasing or decreasing at the same time. But now we have one is increasing, other is decreasing. Now move toward the second type of molecular vibration, which is the bending vibration. It has low energy. Our stretching vibration has high energy. Of how much it has? 4000 to 125 centimeter per mole. While the energy of your bending is low, it's about 1400 to 666 centimeter. So now you can see the difference between the energy of stretching and the bending. Stretching always have high energy, while the bending vibration always have low energy. Now you can differentiate the stretching and the bending vibration. Now the bending vibration, these are the oscillation that occur perpendicular to the bond axis. Now the bond angle will change, not the bond length. Bond length change in case of stretching, bond angle will change in case of bending vibration. Now the bending vibration again has two types. First is the in plane bending. Now what is in plane bending? Let's study it. I'm gonna to raise all of these things so that you can clearly understand what is in plane bending. So in plane bending is again subdivided. The first type of it is the scissoring. Now in the scissoring, the atoms move closer to each other, okay, and the bond angle will decreases. For example, we have again the three atoms here. This is A, this is B, and this is C, and this is the bond between them. Now the A will bend. It will move towards the C, and C uh, and the C will move towards the B, and the bond angle will decrease between them. Like A is moving to that side, after some time you will see them nearly or close with each other, okay. Like now first the bond angle is like 60, now the bond angle is like 45. The bond angle between them is decreased. Second type of in plane bending is the rocking. In the rocking, the atoms will move in the same direction. Whether they move like up, C will also move up. Whether they are moving down, C will also move down. So both are in same direction, they will move. This is called scissoring or rocking. The second type of bending is the out of plane bending. Again, out of plane bending has the two types, as the in plane bending has. Out of plane bending has the first type, which is called wagging. In the wagging, atom move in the opposite direction of the plane. For example, three atoms again here, A, B, and C. A will move like upward, and C will also move in the opposite direction like that. इस तरह, ठीक है, इस तरह. Now atom moves in the opposite direction and they are moving in out of the plane. Second type of out of the plane bending is the twisting. Twisting in which one atoms move upward, like A is moving upward, but now C will move downward. Okay, like that. So A will move up, B will move down. In wagging, both are moving in opposite direction but out of plane. But in twisting, one is moving upward, other is downward. In scissoring, both are coming close to each other. In rocking, both are atoms move in the same direction, both are moving in the same. In stretching, we have symmetrical or asymmetrical. In symmetrical, the bone length increase and decrease simultaneously, while in asymmetrical, one is increasing and other bone length is decreasing. So these are the types of stretching or vibration. In stretching, the energy is high. In bending, energy is low. In stretching, the oscillation is occurring along the bond axis. Bond length will change here. But in bending vibration, the vibration is occurring perpendicular to the bond axis. Now we have the change in the bond angle. So this was all about our IR spectrometry. So we have discussed the introduction of it. In the next lecture, we will study about the types of the IR spectrometry, which is very important for the paper point of view. In this lecture, we have studied what is IR spectroscopy, what is it is, and then we have discussed what are the electromagnetic spectrum and where it is present, what the region it has. Then we have see its principle, that its principle is the molecular vibration. Molecules vibrate, molecules become a ball, and the bond between them is like a spring, and the dipole moment change between them, and more if we give intense IR, more will be the dipole moment change. Similarly, we have seen the types of molecular vibration which are in front of you: stretching and bending. Stretching is symmetrical, asymmetrical, in which the oscillation occur along the bond axis. Bond length will change, high energy. In the bending, the oscillation occurs perpendicular to the bond axis, and here the bond angle will change. In plane, out plane, in plane, scissoring and rocking, outplane, wagging and twisting. So this was all about the today's lecture. I hope you find this video well. If you like this video, please subscribe to my channel, press the bell icon, and also like my videos so that you can get the notification of further upcoming videos. Take care, meet you soon in the next lecture. Allah Hafiz.